We're going to practice doing combustion analysis in this question. So in this question, first thing first, you want to know combustion analysis is as follows. Combustion is when you are, let me just change the color of the pen. So when you have some kind of sample, right? So this sample is usually made out of carbon, hydrogen, and sometimes oxygen, sometimes also include nitrogen. In this question, it is only include carbon, hydrogen, and oxygen. So we know that. In the case of not given, whether it has oxygen or not, you need to be checking for the oxygen. Okay, so let's get started. Combustion is always reacting with oxygen, right? It's burning, infused, and it's gonna release CO2 and H2O. Notice that this is not a balanced chemical reaction because I am just simply writing down what is combustion. So in this case, you will see that the carbon dioxide carbons is basically come from the sample carbon, right? For the hydrogen, same thing. Hydrogen of the water is come from hydrogen of the sample. Now, looking for the oxygen is a little bit more tricky because oxygen in this case is found in carbon dioxide and also found in water, and both of these are actually coming from the oxygen that is part of the reactant used to burn this sample and also part of the sample. So it's a little bit different, but let's get started. So again, like I said before, all the carbons is gonna form in the carbon dioxide. So I gotta need to find the carbon dioxide, which is here. So I just simply gonna grab that. And then, so what I'm gonna do is I need to convert that gram of carbon dioxide into mole of carbon dioxide. So let's see how this is gonna done. Okay, gram of carbon dioxide, let's convert that, is 1 mole of CO2 is gonna be equal to, you're gonna do molar mass using periodic table. So carbon is 12.01 oxygen, each oxygen is 16. So therefore total is 44.01 gram of CO2. Okay. Next is we're gonna convert that mole of CO2 into mole of carbon. So you will see that there is 1 mole of C in a 1 mole of CO2. Okay. I'm gonna go ahead and skip over and then go ahead and do the next setup. This one you're just gonna do multiply divide to solve for this. So when I do the hydrogen. Hydrogen is pretty much the same way. In fact, you can see that I'm going to copy this so you can see that most of them are essentially the same. Right, so I'm going to pick up the water vapor. So that's going to replace this. Right, so we're going to use water. So that means I'm going to need to use water here. So that should say H2O. So let's get that. Move over. We're doing H2O. Right, and then the molar mass of H2O is 1.01 times 2 because 2 hydrogen plus oxygen, which is 16, so therefore total is 18.02. Again, now we just need to do H2O again. So this should be the mole of H2O. Notice that in the 1 mole H2O, you don't have 1 mole H, you're gonna have 2 mole H. Okay, so if you need to, go ahead and calculate these. I'm gonna go ahead and do that myself right now. 2657 divided 44.01. We're gonna get at 0.006. Let's see, 46, so 0.037, and that's gonna be mole of C. Okay, so I'm gonna do the same thing here. 0.0543 divided by 18.02 times 2, we're gonna get 0.0060266. No, I'm just gonna round it a little bit more. That's okay. Or you can say 67. 27. Okay, mole of H. Okay, now we're gonna need to find oxygen. So this is where you kind of have to do a step later. of this. So we need to find each mole in the gram. Okay, so each mole in the gram. So when I multiply by same thing, molar mass. So that means 12.01 gram of C divided by 1 mole of C. We're also going to do the same thing, right? 1.01 gram of H divided by 1 mole of H. The reason we had to do that is because you, like how I would say initially, your sample is made out of CHO. So we're going to be using this sample, which is like I said, is made out of CHO, right? And we basically gonna do is we're gonna subtract whatever we get, right, from the carbon and the hydrogen, and that should give us the oxygen. Okay, all right, so let me go ahead and do that. So this one is gonna give me 0.00608.7, okay, gram of H. Again, if the number is off a little bit, that's because I have stored these number in my calculator, so that's why it is possible that your number is off a little bit from what I have before. Okay. So anyway, so which I will share with you guys in class later how to do that on the calculator. Okay, so that will give me 0.07250 7, so 251 gram of C. So again, we're just simply subtracting. Again, you want to do that in a class when you're solving for these. If you don't know if they have an oxygen or not, you want to subtract it, and after you subtract it, if there is no more stuff left, that means no oxygen. Okay, so that plus, let me see, not plus, but I'm doing a little bit differently. 0.1752, we're gonna get 0.096. Okay, notice that should be 4 decimal places because we're adding and subtracting, not multiplying. So 6, good enough. That will be gram of O. Now that we have a gram of O, hopefully you know what we're coming out next. We're just gonna convert that gram of O into the mole of O. Alright, so 1 mole of O, 16 gram of O. Okay, so again, let's go ahead and do that. Divided by 16. So that should give us 0.00603. 0378, so 038 mole of O. Now that I have those 3, we're just gonna do empirical formulas, which means simply mole ratio. So go back and pick up the mole of each one, since we're gonna be doing ratio of those. Okay, so remember, when you're doing mole ratios, what you're gonna do is you're gonna divide them by the lowest number. So let's see, the lowest number was, in this case, they seem to be equally small. So yeah, just divide by any of this will work. So anyway, so just divide by any of these will work. So let me see. I mean, you can see that they're essentially the same thing. So that will be basically 1 to 1 to 1 ratios, I would say. But this is the smallest one, hydrogen. So essentially. Okay, so that means you're having CHO on that one. I have a feeling I give a round number, but let's see. And then now here, we want to figure out molecular formula. Before we do it, we need to find the molar mass first. That's easy. We got gram, we got mole. Molar mass is simply gram over mole. So we're gonna go ahead and do that. 0.175 gram divided by 0.00151 mole. So So let's go ahead and do that. 0.175 divided by 0.00151. We're going to get 115.9 gram over mole. That's the molar mass. And for the CHO is 12.01 plus 1.01 plus 16. So that would be 29. So we have something wrong with this question. I probably messed up on one of these numbers. Not sure what did I did. Carbon dioxide, water. Let me see. Carbon dioxide, gram, mole. Okay. And then gram, mole. Okay, we got that. We have mole to gram, subtract, and then find a mole. Okay, let's see. 6037 divided by 0.006027. Yeah. Okay. It's just a really weird question. I think I messed up on the numbering, but anyway, if I had done the correct numbering, we will get a little bit differently. Let me give you another question, but I'm gonna finish this one up. So this is gonna have to be there. Okay, to find molecular formula, what you're gonna do is you're always gonna find the empirical formula mass first. So this is the empirical formula. So empirical formula mass is equal to 12.01 plus 1.01 plus 16, right? So we're gonna do that. So we said 29.02 gram over mole. And then what you're going to do is you're going to divide the molecular formula mass by the empirical formula mass. So 115.9 divided by 29.02. Right, so 115.9 divided by 29.02, we get about 3.99. So we're going to say that is approximately full. So then we get the formula of C full H full O full. Like I said, it's a really odd formula because I might have made a mistake on it, but that's okay. We can still write it. The idea is still the same thing. Let me make you another question that make it a little bit easier or give you better formula. So hold on a second. Let me just finish that. You're still gonna do like how you did it with the earlier one that I show you, except now what you're gonna do is you need to balance this. I'm not sure if this one will be balanceable since I sort of messed up earlier, but let's see. Okay, so we got C is full. Let's try that. H is full, so let's try that. Again, this formula is completely weird, but that's okay. So let's see, O is 2 times 4, so that's 8O plus 2O, so 8, 9, 10. Okay, so there's 4 already there. So 10 minus 4 is 6, so therefore I need 3 there. 3 times 2, so we'll make 6, and that's balanced. Okay, all right, so that's that.